My name is Avin Patel.
Michael Dillon.
Sam Capilongo, and we're group 1079.
The situation that we're dealing with is something called continuous passive movement. After surgery, intense joint surgery such as elbow or knee surgery, keeping the joint moving for several hours a day is essential in helping the damaged tissues heal. However, moving a joint, a leg or an elbow for 8 hours a day is just not an easy task. Moreover, the solutions that we have in America are not easy to come by in less fortunate countries.
There are a couple of solutions to continuous passive movement. The one most commonly used in the United States is the CPM machine. This machine it basically takes the joint and moves it for continuously for a long period of time. Other solution, which is more practical in third world countries, is when someone sits by the patient and moves the joint manually for continuous hours, which is just not a practical solution for them.
The problem with the current solution today is that in the developing world, a $7,000 machine is extremely expensive. Two, it requires, constant power at all times. A lot of the machines have to be plugged in, and those that run on battery have to be plugged in to be recharged. So with an unstable grid in the third world, it's difficult for those machines to be in effective use. The next problem with somebody being in the room and just moving the injured person's arm or leg consistently is, now you're taking somebody else out of their normal routine of their day and inconveniencing them, along with making them have to sit there and move an arm or a leg back and forth just to the perfect angle so that it doesn't hurt the patient too much, but it's actually providing some type of treatment. So the combination of those two really make the current machine too difficult to use in third world developing countries.
Our solution is the Joint Mover 3000. The idea arose from the concept of how a shade for a window works. The base of the product actually holds the motor of an automatic shade. The patient will lie to the side of the machine with the brace supporting the necessary limb. Attached to the brace is a cord, which is hung over a pulley with a counterweight on the opposite end. By a push of a button, the pulley rotates, lowering the weight and extending the limb. The Joint Mover 3000 is then put in reverse, returning the limb to its original bent position.
So there are a couple of reasons why the Joint Mover 3000 is 10 times better than a CPM machine. The first one being is a CPM machine is $7,000, and that's difficult for a lot of American families to purchase. It's nearly impossible for any family in a developing country to purchase. It's very portable, so we are able to get it to these less fortunate countries very, very easily. It's battery operated, so there's no needed power source, no needed grid for anyone in a situation where they're not able to afford such devices that need to run on such electricity. And the last one is it's much, much more efficient than a grandmother or a mother or a father simply moving the arm or leg for basically the entire day. It takes time out of their day. It is very strenuous on that person who is doing the movement, and pushing a button to have this device go up and down a couple times a day is much more simple.
In conclusion, the Joint Mover 3000 is the most effective choice. Now, grandmother doesn't have to sit next to the child and continuously move the joint for hours. Also, it's battery operated, which means that third world countries can easily afford this machine by just replacing the batteries when they run out.
Above all, it's much cheaper. A CPM machine is over $7,000. Our product is merely a few hundred. Although it's not zero like grandma's solution, it is still a gigantic step away from the CPM machine's $7,000.
Combining these two aspects, it's easy to see where companies might decide to become a bit more philanthropic. The idea that it's cheap and we can start helping third world countries, and honestly production costs wouldn't be much. You can bulk order batteries for maybe $1 or $2 a piece, Even if they run out on occasion, you're still only looking maybe $10 of batteries investment into an entire use for one patient. On top of that, we can buy one of these machines now for around $300. Once we start talking bulk, the cost to these guys are going to reduce greatly. That being said, we would still need some type of a startup cost. We figure between some extra research and development and the final production line, it would be somewhere in the neighborhood of $100,000. You're probably looking for somewhere in the neighborhood of fourfold on your return.